So I'm going to record a video explaining the questions on this worksheet. Here's a quadratic formula. X equals negative b plus or minus the square root of b squared minus 4c all divided by 2 times a. And of course, when you use this formula, I want you to always rewrite it and then rewrite it with parentheses. Negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. Okay, I always want you to rewrite it with parentheses before actually applying the quadratic formula. So we've already done a couple of these together in class, so I'm just going to jump to the one we haven't done yet, which is, let's say, number 3. Let's start with number 3. So hopefully everybody goes to number 3 and works on this as I work on it. The first thing to do is to write down your quadratic formula. So there's a quadratic formula, and of course, whenever you use the quadratic formula, I really want you to rewrite it with parentheses. That way you could safely plug in your values, okay? So the a value is clearly the 1, the b value is clearly the negative 4, and the c value is clearly the 6. Again, include the signs that are in front. That minus sign belongs to the 4, so the b value is negative 4. So when you look at the b values, it's this first one and this first one inside the root. We're going to plug in the b value of negative 4 right there and right there. Okay, very important that you use parentheses when you're plugging in values. Again, the a value is 1, so we plug in the a value right there, and the c value is 6. It goes right here. And when you start working on the quadratic formula, you begin with the discriminant, which is the value inside the root. Okay, bless you. When you work with that, you're going to begin with the negative 4 to the second power. Negative 4 times itself is positive 16. And then you could now deal with the minus 4 times positive 1. Minus 4 times 1 is still a minus 4, but then minus 4 times 6 becomes a minus 24. So you really have a minus 24 right there. Again, we got 16 minus 24. There it is, 16 minus 24. And 16 minus 24 is, it's negative 8, okay, negative 8. So my discriminant is negative 8. Now, at this point, we could stop and say no solution, okay? We could stop and say no solution. Now, the reason for that is the discriminant's negative. So let me show you what would happen if I kept going. Well, we're going to change the minus minus to a plus plus. So we're going to have a positive 4. We're going to have the plus or minus. We have the square root of negative 8 because that's what was inside after simplifying it. That's your discriminant value over 2 times 1, which is 2. Okay. Now, if you try to do this on the calculator, it'll say error. That's because this is an imaginary value. So this answer in algebra 2, you would work it out by putting the I value. The negative comes out as an I. You end up with I square root of 8, and you keep going in algebra 2. But in algebra 1, we could just stop right there and say, there's no real answer. You're going to say no solution. Or you could put a circle with a line through it. That means no solution. That means there's no real answer. That means that there's no real x-intercept. There's no real solution, no real roots, no real zeros, right? Whatever phrase you want to use on it, there is none. Okay, the parabola opens up and it will not cross the x-axis. So that means that the vertex is above the x-axis. I hope that makes sense. Let's move on. Number 4, again, begin with the quadratic formula. And then from there you rewrite it, but with parentheses. And then from there you safely identify your a value is 1, your b value is negative 6, and your c value is 7. Okay, so let's plug in our negative 6 into the b's, our 7 into the c, our a value of 1 right there and down there. Now, let's continue on here by working on the discriminant. The discriminant is the value inside the square root, the negative 6 squared minus 4 times 1 times 7. And when we begin with that, we're going to begin with the exponent, negative 6 to the second power. That's negative 6 times negative 6, which is a positive 36. And then we could do the minus 4 times 1, that's a minus 4, and then minus 4 times 7 is a minus 28. Okay, so 36 minus 28 is, so we get 8 as a discriminant value. okay? Inside the square root, there's just an 8. You don't need all this junk. It's just 8. We already did the math. So from there, we're going to change the minus minus to plus plus. So you're going to have a positive 6. You still have the plus or minus. Now, the square root, all you have is an 8 in there, okay? And then it's divided by 2 times 1 is 2. Now, the square root of 8, you could do it by hand, or you could get a calculator and type in the square root of 8, and it'll simplify it for you. Let me simplify the square root of 8 for you right here on the side. Square root of 8 is not a perfect square number. You want to rewrite it with multiplication to get a perfect square number. A perfect square number is like the number 4, and 4 times 2 is really 8. And then you could take the square root that was originally on the 8 and split it to the 4 and to the 2. Then you could actually do the square root of 4, which is the nice number 2, no more square root. And the square root of 2 just comes down square root of 2. Okay, so what I'm saying here is that the square root of 8 really becomes 2 square root of 2. So I'm going to replace this square root of 8 with 2 square root of 2. And I'm going to rewrite everything else. The plus or minus is right in front of it. That red 6 is right in front of it. And that 2 at the bottom is right there at the bottom. So I hope we understand that the square root of 8 got replaced with 2 square root of 2 because square root of 8 is 2 square root of 2. You could do this on the calculator. Anyway, this is our final answer. However, we need to reduce this final answer. And you have a 6, a 2, and a 2. So you're going to reduce by what? By 2. So 6 divided by 2 is 3. 2 divided by 2 is 1, which you're not going to have to write. 2 divided by 2 is 1, which you're not going to have to write. So our final answer is 3 plus or minus 1 square root of 2. I'm just going to leave it as square root of 2. And I am not going to put it over 1 because it's unnecessary. On a multiple choice test, that's what you're going to see as your final answer. 3 plus or minus square root of 2. So right here on number 5, one option is to do that long multi-step factoring method, right? Where you say, oh, the A value is 2, the C value is negative 5, multiply A times C, you get negative 10. Step 2 is to make a list of the multiples of negative 10 that combine together to give you the 9. Step 3 is to rewrite it in parentheses AX and AX. But if you want to avoid factoring, you could always use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then again, you're supposed to rewrite it with parentheses instead of the letters. Negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. Once you identify that your a value is 2, your b value is positive 9, and your c value is negative 5, you could plug in those values. So b of 9 goes right here and right there. The a value of 2 goes right there, and the c value of negative 5 goes right in there. Working on the discriminant first, which is the value inside the square root, you're going to begin with the 9 to the second power. 9 to the second power is 81. I always write this number on the side. And then I do minus 4 times 2. Minus 4 times 2 is minus 8. And then minus 8 times minus 5. A negative times a negative is a positive. That would be a positive 40. So you really have 81 plus 40, which ends up being 121. 121, okay? So we're going to be able to rewrite this thing. X equals negative 9 plus or minus the square root of 121 instead of all that stuff up there, okay? So we have the square root of 121, and it's still divided by 2 times 2, which is 4. So from here, we want to simplify the square root of 121. You could do it on a calculator, or you should know that that's a perfect square number. So what is the square root of 121? That's correct, it's 11. So let's rewrite this thing. We really have negative 9 plus or minus the nice number 11, no more square root, all divided by 4. So the plus or minus actually produces 2 answers, okay? We're going to go negative 9 plus 11 divided by 4, and we're also going to go negative 9 minus 11 divided by 4. So up on top, negative 9 plus 11, that'll be 2 divided by 4, and that reduces down to 1/2. And on the bottom, we have negative 20 divided by 4, which ends up being a negative 5. So our 2 answers to this quadratic equation is 1/2 and negative 5. the quadratic formula will always work, okay? You could have also factored, split, and solved using that long method of factoring, and you'd still get the same answers, 1/2 and -5. Everybody go to number 6. We could jump right into using the quadratic formula, but what I would like you to do is to look at the equation and recognize that this is a 2, this is a 12, this is a 10, this is a 0. Now, the beauty of solving equations is that you could do whatever you want to an equation as long as you do it to both sides of the equation. So if you wanted to, you could make this equation easier by dividing everything by 2. Divide that by 2, that by 2, that by 2, and even the 0 by 2. Okay? What's going to happen if I divide everything by 2? Well, that becomes a regular x squared, and that's nice. This guy becomes a regular plus 6x, and this guy becomes a 5 plus 5, and it is still equal to 0 divided by 2 is still 0. So by dividing everything by 2, it becomes a nice, super easy equation. Now, you could have used the quadratic formula right from the start. The a value is 2, the b value is 12, the c value is 10. You'd still get the same correct answer, but isn't it easier to work with the a value of 1, the b value of 6, and the c value of 5? Absolutely. Another thing I would like you to do is to recognize that since there's no number in front of the x squared anymore, maybe you could factor and rewrite it as 2 binomials being multiplied together. And of course, x times x gets you that x squared. All you got to do now is think what times what is 5 that if you add together is 6. What times what is 5 that if you add together is 6? What times what is c that if you add together is b? Well, what times what is 5? It's going to be a 1 times 5, and that's it. And if I do add 1 and 5 together, it does give me 6. So that's the right combo. I could put a 1 right here and a 5 right there, and I have factored it. Which means I could now do zero product property. That means if you have something times something and it equals 0, that first something, x plus 1, could be 0, and the second something, x plus 5, could also be 0. Giving you 2 quick answers a lot faster than the quadratic formula. So your 2 answers are -1, x equals -1, and -5, x equals -5. Those are your 2 answers right there. So I recommend if you could see an equation that you could actually factor, split, and solve, especially on a quiz or test, please do so. But if you wanted to practice using the quadratic formula, you could have, right from the start, called this A, this B, this C, and you could have done the quadratic formula. It would have given you these same 2 answers anyway. Likewise, you could have gone to Desmos and graphed this quadratic trinomial, and it would show you a parabola that opens up that crosses at -1 and -5. Jumping to number 7, what do I do first? Before even trying to factor, before even using the quadratic formula, or even if I wanted to graph it on Desmos, what would I have to do first? Get rid of that -12, make it 0. You have to make it equal to 0 before identifying A, B, and C. So you're going to go plus 12, which you can't really do. You're going to rewrite it, 2x squared minus 9x plus 12 equals 0. Now you could safely identify your A value of 2, your B value of -9, and your C value of +12. So you could use a quadratic formula. I even used different colors so you could easily see the B, the A, and the C. And of course, rewrite it with parentheses. And then plug in your A, your B, and your C values. So your B value is -9, that goes right here and right there. The A value is +2, that goes right here and right there. And the C value is 12, that goes right here. You always begin with the discriminant, the value inside the root. So that value inside the root, you begin with the exponents, -9 squared. -9 times itself is +81. And then you go -4 times 2, that's a -8. And then -8 times 12 is a -96. So -96. So what's our discriminant going to be? It's going to be a -17. No, 15. Okay. So right here we could stop in Algebra 1. In Algebra 2, you'd have to keep going, but in Algebra 1, you're going to have +9 plus or minus the square root of -15, which we know is imaginary. It's still over 4. Okay, so you could just stop right there and say no solution. No solution, no x-intercepts, no answers, no real zeros. It's imaginary, right? In algebra 2, you're going to have to take this minus sign and move it out. And in algebra 2, you'd have a 9 plus or minus I square root of 15 divided by 4, and that would be your answer in algebra 2, okay? Which is an imaginary value. But in algebra 1, we could just stop right there and say no solution. You get it? Okay. Right here on number 8, what do we need to do first to start solving this thing? Whether you're using the quadratic formula or not, or whether you're graphing on Desmos to find the x-intercepts, what do you need to do first? Set it equal to 0. That's right. So we're going to get rid of that 12 by subtracting 12. And what you do to one side, you must do to the other. Subtract 12. Your new quadratic trinomial equation will be 2x squared minus 5x minus 12 equals 0. And now you could clearly identify your a value, your b value, and your c value. And you could use a quadratic formula. Okay. Maybe it'd be a good idea to show you how you could have probably solved this using factoring methods, right? You know what, I want to do both methods, okay, on this one. So you could, if you wanted to, you could use that old method. I hope we remember. Step 1, when you have a quadratic trinomial equation and there's an actual number out here in the front, is to multiply a times c. A times c. A times c is negative 24. And then step 2, if you remember, is to think of the multiples of that answer, negative 24. So negative 1 times 24, negative 2 times 12, negative 3 times 8, and negative 4 times 6. And then you think of these pairs of numbers that multiply together to give you negative 24, you could combine, or you got to combine them and see which ones combine together to give you the middle value, negative 5. Okay, so this is a good review of chapter 8 that we've done in the past. And if you add 24 and minus 1, that's 23. That's obviously not a 23. If you add 12 and minus 2, that's 10. That's obviously not a 10. 8 take away 3, that is 5. And that is a 5, but it's a negative 5. So we have the right number, just the wrong signs, which means we have the right numbers, just the wrong signs. So we're going to change the minus 3 to a plus 3 and the positive 8 to a negative 8. Does anybody remember step 3 of this long process of factoring? It was set up your parentheses, your binomial times binomial, and you put your ax term on the first part of each binomial. In this case, ax, a is 2 with an x, so that would be 2x and 2x. And you put the pair of numbers from step 2, this pair of numbers, you put them right here in that blank spot and right there in that blank spot. So the plus 3 goes here and the minus 8 goes there. So we have a plus 3 here and a minus 8 there. And then from there, step 4 is to magically divide each binomial by whatever you can. So the first one, the 2x plus 3, you can't divide by anything, so that's going to stay 2x plus 3. The second one, you could actually divide both of these by 2. So if you divide both of those by 2, you'll get 1x minus 4. And ladies and gentlemen, this is the correct factored form, which means you could rewrite this quadratic trinomial as this binomial times that binomial, and it'll still be equal to 0. So technically, I still have an equals 0 right here. So I really have this binomial times that binomial equals 0, which means I could use 0 product property to separate them. So 2x plus 3, that could equal 0, and x minus 4, that could equal 0, giving me two answers. This one, you're going to get rid of the plus 3 by subtracting 3, and then rewriting it, and you'll have 2x equals negative 3. And then you're going to finally divide by 2, x equals negative 3 halves, or negative 1.5. And the other one's easy, plus 4, x equals 4. So you have two answers, negative 1.5, negative 3 halves, and also x equals positive 4. That was using the factoring method, that long factoring method that we learned in Unit 8. If you forgot this, that's okay. Why? Because the quadratic formula always works, okay? So I just wanted to show you that you could use the old factoring methods if you want. But right now, I'm just going to go back to here and jump right in with the quadratic formula. So let's write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then we're going to replace the b's, the a's, and the c's with parentheses. And of course, we know that our b values are -5, so that goes right here and right there. So -5 goes right in there. And then our a value is 2, so we're going to put the 2 right there and right there because that's where the a values are at, right there and right there. Put in the 2's right there. And finally, we have the c value of -12, which goes right in there. -12, okay? Now, whenever we apply the quadratic formula, you begin by simplifying the discriminant value, which is the value inside the root. And I always start with the exponent, -5 squared. -5 times itself, that's +25. So I just put a 25 right there. And then from there, I think -4 times 2. -4 times 2 is a -8. And then a -8 times -12. A negative times a negative is a positive, and 8 times 12 is 96. Okay, so 25 plus 96, that'll be 121, I believe. So what that means is that you could rewrite this discriminant as that simple number 121. So let's rewrite the whole thing. A minus minus becomes a positive, so you have a +5. You still have the plus or minus. You have the square root, but we're going to put 121 instead of all this junk. We're just going to put a 121 right here. And it's still divided by, but I'm not going to put 2 times 2. I might as well do 2 times 2. 2 times 2 is 4. Okay, now at this point, whenever you get to this part of the quadratic formula, you have to simplify the square root. The calculator will do that for you if you blank out. But we should all know that 121 is a perfect square number. The square root of 121 is 11. So I'm going to rewrite this thing as 5 plus or minus 11. No more square root. The square root of 121 is 11 divided by 4. And that plus or minus actually produces 2 answers. You have the first answer, 5 plus 11 divided by 4. And you have the second answer, 5 minus 11 divided by 4. Okay? So we're going to work on both of these, and we're going to get 2 separate answers. So the first answer up here, 5 plus 11, that's 16, and 16 divided by 4, that's 4. That's one answer. The other one, 5 take away 11, that's -6, and -6 divided by 4, you can't really divide by 4, but you could reduce by 2, and that'll be -3/2. And that's it. Those are your 2 answers. X equals 4, and x equals -3/2. If you compare that to the original method that I did, which is on with that long factoring method, I think I would like to do the quadratic formula instead of this long factoring method, but it's totally up to you. But you see, the quadratic formula will always work. Sometimes when you're trying to do this long factoring method and you're thinking what times what is this answer that combines together to give you the middle value, you're not going to be able to do it because it's not factorable. But the quadratic formula always works. Jump into number 9. All right, what do I do first? All right, so how do I set it equal to 0? -4 on both sides. Thank you so much. We will have an equals 0 right here. But of course, if you subtract 4 on one side, you have to subtract 4 on the other. And you can't really subtract 4 from x or from 3x squared. So you're just going to rewrite the whole thing. 3x squared plus that 1x minus 4, and now it equals 0. And now you could clearly identify that your a value is 3, your b value is 1, and your c value is -4. And we're going to use those values to plug it into the quadratic formula. And of course, when you use this quadratic formula, I want you to replace the letters with parentheses so you could safely plug in your a, your b, and your c. So our b value is 1, is going to go here and here. Our a value of 3 is going to go right here next to the 4 and down there next to the 2. And our c value of -4 goes right into that last parenthesis. Once again, we need to begin with the discriminant, the value inside the square root. And we're going to just draw an arrow. We're going to begin with the exponent. 1 squared is 1. And then working from left to right, a minus 4 times a 3, that's a minus 12, a negative 12. And then a minus 12 times a minus 4, a negative times a negative is a positive, so you put a plus sign, and 12 times 4 is 48. So that means our discriminant is 1 plus 48, which is 49. And that's a beautiful thing because 49 is a perfect square number, right? So if I rewrite this thing, negative 1 plus or minus the square root of 49 divided by 2 times 3, which is 6, right? Divided by 2 times 3, which is 6. And then you could actually simplify the square root of 49. What is the square root of 49? If you forgot, use a calculator, but that is 7. So you have a negative 1 plus or minus 7 divided by 6. And again, the plus or minus is what's producing two answers. You have the negative 1 plus 7 divided by 6, and you also have the negative 1 minus 7 divided by 6. So up on top, negative 1 plus 7, that is 6, and you still have it divided by 6. Final answer is 1. Boom. Okay, the other one, down here, a negative 1 minus 7, that's a negative 8. And negative 8 divided by 6, you can't really divide by 6, but you could at least reduce by 2, and that'll be a negative 4 over 3. Negative 4/3 is the other answer. So those are your two answers right there. That's how you use the quadratic formula. Could have this been done differently? The answer is yes. Okay. You could have used your skills from chapter 8. Let me rewrite the problem here. 3x squared plus 1x minus 4, right? That is equal to 0. You could have said, okay, multiply a times c, and you get that first value, then you make a list of the multiples of that answer. But you know what? As we found out on the other question, the quadratic formula works great. The only time I would actually go for factoring is if you would have no number in the front. Like, for example, number 2 here, super easy. There's no number in the front. You could set this up, factor it, put the x in the x, and think what times what is 7, the c value, that if you combine together is 8. You might have to make a list, but there is no list. It's only 1 times 7. And when you add 1 and 7, it does give you 8. So 1 and 7 are the correct combos, and that is factored. So this quadratic trinomial really does equal x plus 1 times x plus 7, and that still equals 0. And now you could actually use zero product property and split them. You could say this times this equals 0. That means that the first x plus 1 could equal 0, and the second x plus 7 could also equal 0, giving you your two answers, x equals negative 1 and x equals negative 7. So if you're able to factor and split it and solve the way I just did, that'll save you some time because the quadratic formula would take way longer. So I say, look at your problem, see if you could factor it. If you could, factor, split, and solve. If you can't, then go for your quadratic formula, right? So number 1, you could factor as well, parenthesis, 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 x. What times what is negative 3? That if you combine together is 2. That'd be a positive 3 times a negative 2. And if you split them, x plus 3 could be 0. X minus 1 could be 0. You get your two answers. X will be negative 3 and x will be positive 1. That's way faster than doing the quadratic formula. But as we saw over here, when I did this one with that factoring method, which was a multi-step process, that took just as long, probably even longer than using the quadratic formula. So when you don't have a number out in front, try to factor it. If you do have a number out in front, I just say jump right into the quadratic formula. Okay, there's a couple more on this first half of the worksheet I want to do. Let's do number 10 right here. Let's set it equal to 0 first by adding 8x to both sides. Now, since there is no other x term, there's an x squared term, but no other x term, so I'm just going to rewrite the whole thing. And once you have it set equal to 0, of course, you probably want to write down your quadratic formula. And of course, you want to rewrite it with parentheses, negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Write it with parentheses. That way it's really easy to plug in your a value of 3 into the a right there and the a right there. So that's a 3 right there and a 3 right there. The B value of 8, that goes into the B spot right there and the B spot in front. So put an 8 right in there and an 8 right there. And the C value of -1, that goes right there, okay? When you have it set up, you always begin with your discriminant, the value inside the square root. So the value inside the square root, 8 squared, 8 times itself, that is 64. And then I always call this -4, I pretend it's a -4. -4 or -4 times 3 is a -12. And a -12 times -1 is a +12, so plus 12. So you really have the 64 plus 12. And 64 plus 12 is 76. So our discriminant is 76. Okay, so I could rewrite this thing, -8 plus or minus the square root of 76 over 2 times 3, that is 6. Okay, now the question is, what is the square root of 76? With these awesome calculators, you could hit that square root button and type in the 76 right in there, hit equal, and it'll actually simplify it for you. Okay, 2 times the square root of 19 is what the simplified form is, right? If you didn't have a calculator, what you would have to do is simplify by hand. Let me show you that right here on the side. 76. 76 is not a perfect square number. You want to rewrite it with multiplication to get a perfect square number. 4 times 19, that's what it would be. 4 times 19. And then you could split the root, and that would give you 2 square root of 19, right? But of course, the calculator could do that for you, 2 square root of 19. Anyway, we're going to replace that square root of 76 with 2 square root of 19. So what we really have is -8 plus or minus 2 square root of 19 divided by 6. Now, at this point, we have 3 terms, 1, 2, 3. This is your answer. However, you have to reduce your fraction. So you have an 8, a 2, and a 6. What could you reduce everything by? You could reduce everything by 2. 8 divided by 2, or -8 divided by 2 is -4. 2 divided by 2 is a 1, which we're not even going to put in front of the square root of 19. 6 divided by 2 is 3. So here's our final answer, -4 plus or minus. You don't need the 1 in front of the square root of 19, all divided by 3. There's your final perfect answer for this question number 10. A lot of students mess up on this last part. They do all this correct work, and then they forget to, they look for this answer on the multiple choice on the final exam, and it's not there because they always write their answers in simplified form. So you have to be able to reduce this fraction, 8, 2, and 6, reduce it all by 2, and you will get this as a final answer. So this one will be the last one on this video. Let's make it equal to 0 first. No matter what, even if you're graphing it on Desmos to find the x-intercepts to get the answers that way, you still need to set it equal to 0 first. So subtract 15 on both sides, rewrite it. You'll have 4x squared plus 7x minus 15 equals 0. And now you could identify the a, the b, and the c. That way you could plug it into the quadratic formula. And of course, when you use the quadratic formula, rewrite it with parentheses. That way you could safely plug in your b value of 7 right here and right there, the a value of 4 right there, and the c value of -15 right there. And of course, we begin with our discriminant. The discriminant is the value inside the square root. And you begin with the exponent, 7 squared, that's 49. I'm just going to do this work up here on the side, 49. And then I have a -4 times 4. -4 times 4 is -16. And then -16 times -15, that's going to be a positive 240. So 49 plus 240 is 289, right? Okay, so we're going to rewrite this thing, -7 plus or minus the square root of 289, all divided by 8. So what is the square root of 289? You could use a calculator, and I just used the calculator. That answer is the nice number 17. So with the calculator, we found out that the square root of 289 is 17. So we have -7 plus or minus 17 over 8. Now that plus or minus produces 2 answers. It'll give you negative 7 plus 17 divided by 8, and also negative 7 minus 17 divided by 8. So let's work on both of these answers. Negative 7 plus 17, that's 10. 10 over 8, you can't do it, but you could reduce by 2. That'll give you a 5 over 4. And the minus 7 minus 17, that's a minus 24. And that's divided by 8, which you could do, and that'll be a negative 3. So your two answers are 5/4 and negative 3. Okay. Could this have been done a different way? Yeah, you could have factored, split, and solved, but that's very complicated in itself. If you wanted to, you could go to Desmos and type in 4x squared, actually y equals 4x squared plus 7x minus 15, and it'll show you a parabola that opens up with a modified pattern, and it does cross the x-axis at negative 3 and at 1 1/4, at 1 and 1.25, I guess. Anyways, that is the first half of this worksheet, which was all on solving using the quadratic equation, but on a couple of them, we factored, split, and solved, which was even easier than the quadratic formula. The second half of the worksheet, which I'll do in a different video, is just finding the discriminant, all right, the discriminant. And the discriminant is the b squared minus 4ac. And if that discriminant ends up being negative, then you know that inside the square root of your quadratic formula, you'd get an imaginary value, right? You can't do the square root of a negative. So if your discriminant is negative, you have no real answers. If your discriminant is 0, the square root of 0 is 0. And if you add 0, then subtract 0 from any number, it's still going to be that same number. So if your discriminant is 0, you only get one answer. And if your discriminant is any number that's positive, you get two answers. We'll focus in on that on the next video. But for now, we're done.